So what I'm suggesting when we're trying to figure this out, explain a bit about why, is where does x to the power of a half fall in my list? X to the power of a half there. So we're trying to figure out what's here. Now, how do we get from here to here? We multiply by x. All right. Now, this is where maybe putting numbers in is going to help me think about that situation. So let's go with what Sam said to start with. So I'm going to look at, well, if we've got 4 to the power of 0 and 4 to the power of 1, okay, how do you get there? 4. Right, so if I wanted to do 4 to the power of a half, okay, now remember, what I'm doing then is I am trying to find multiply by something, then multiply by something again, all right, which gives me the same as multiplying by 4, which is 2. 2 and 2. So the thing with this number is a lot of people, oh, you half it, that's where the half comes from. Not, is it? Because what if we did the one Sienna suggested, which is 2 to the power of 0, 2 to the power of 1, 2 to the power of a half? Well, we've got to do multiply by 2. So, what do we multiply by? Okay, because we're looking at multiply by something else, gives me the same thing as multiplying by 2, which means these is going to be question mark squared has to be equal to 2. So what must the question mark be? The square root of 2. Okay? And we can check that because is 2 the square root of 4? Okay. So that would suggest then that 1 multiplied by the square root of x is equal to the square root of x, and therefore x to the power of a half is the square root of x. Then, of course, that... Pardon? It is on video. Then that leads us to go even further and go, okay, this explains the next thing. So, x to the power of what's in between 1 and 2? It is, but let's do it in fractions.
1/3.
Oh my word! My top group
3
don't know.
over 2.
3 over 2.
Did it.
Why not 4 over 3?
Because that's not
like
the same
right in
thing.
the middle?
Right in the middle.
See.
Like a half is right. How do we get there? Well, if you think about it, look. Multiply by root x. Multiply by root. Sorry, big jump. Multiply by root x. Multiply by root x again. So what do we end up with? We end up with the square root of x cubed. What's the next one? X to the power of 5 over 2. And that would be the square root of x to the power of 5. Okay, I'll pause there and you can make your notes. And let's have a look at what x to the power of 4, well actually we should do x to the power of a third, x to the power of a quarter, x to the power of fifth, and so on. And we're going to do it by the same process. So we're going to start with x to the power of 0, and I'm going to leave a bigger gap, and that'll give you a clue why. X to the power of 1. Right. How do we get from x to the power of 0 to x to the power of 1? Multiply by x. So if I wanted x to the power of a third, what do I do? Well, I have to split into 3 pieces, yeah? And this would be x to the power of 1/3, and this would be x to the power of 2/3. And then finally 3/3 is 1. So, same process, but this time we have to multiply 3 things, yeah? So let's say, I'm going to say x to the power of a, x to the power of a, x to the power of a, okay? Right? Actually, I'm not going to do it that way, sorry. Right. What do we need to do? So this has got to, I'm going to just do a. That means that x has to be the same as a cubed. Therefore, a has to be the same as the cube root of x. All right? So therefore, x to the power of 0 is 1. 1 multiplied by the cube root of x is the cube root of x. Yeah, simple as that. All right. What would the next one be? Well, what do we get if we multiply the cube root of x by the cube root of x? What? The cube root of x squared. Because you can't simplify it, can you? We have the cube root of x squared. And then a third time we have the cube root of x cubed, which is x, which is x to the power of 1. So it worked. Yeah?
I was like,
You know what the entire thing again. Just give me like summarize the entire thing.
I get it a
Pardon?
little bit.
Yes, it's recording.
Like a little bit.
Okay, wait, let me just write that down.
Yeah.
Well, before you write that down, let's do the next one. Well, it's the same process. It's exactly the same process. So I'm repeating for you, right? I'm helping you understand by repeating. So I tell you what, let's change. Let's not do x. Let's do 7.
I was thinking 7 might have a 3.
I was gonna be like,
7 to the power of 0.
First I was like, why?
7 to the power of 1. Okay. Let's explain what 7. Oh, sorry. I'm not going to do this. All right. Let's explain how we get 7 to the power of a fifth. All right. So, well, first of all, we know that to get from here to here is multiplied by 7. Right? We need to split our journey into bits. Yeah? 1, 2, 3, 4, 5. Okay? So, what do we have? We have 7 to the power of 1/5. That's the one we're interested in. But then we have 7 to the power of 2/5, 7 to the power of 3/5, 7 to the power of 4/5, and 7 to the power of 5/5, or 1. Okay. All right. So, again, what do we have then? Well, we need to split our multiply by 7 into multiply by something, but 5 times, yeah? So, should we multiply by, do you want to give me a, tell you what, let's multiply by beta.
Can we just
Is that German?
Do what you like. No, it's Greek.
Well, I said bees.
Alpha, beta, gamma, you know, all that kind of stuff.
No.
Yeah. Different letters.
Alpha, beta.
So, we want alpha, beta, sorry. Okay,
That's
yeah.
the American way.
Right, so what do we need? We need beta to the power of, this is the important bit, the repeated multiplication. Beta to the power of 1, 2, 3, 4, 5. Right? Because it's repeated multiplication. Has to be the same thing as multiplying by 7. So therefore, beta to the power of 5 has to equal 7. Therefore, the inverse thing that you girls were talking about, beta therefore has to be the fifth root of 7. Okay. Therefore, all right, this multiplied by beta, we now know that's the same thing as multiplying by the fifth root of 7. So if we look at it, what is 7 to the power of 0? 1. What is 1 multiplied by the fifth root of 7? The fifth root of 7. So we now have that 7 to the power of 1/5 is equal to the fifth root of 7. Okay. Now we just follow it on. So we multiply that again. So 2/5 would be the fifth root of 7 multiplied by the fifth root of 7, which is the fifth root of 7 squared. And if we go again, this one would be the fifth root of 7 cubed. The fifth root of 7. And then finally, the fifth root of 7 to the power of 5, which happens to be 7, which is what we wanted. Okay. So, what can we generalize this to? Yeah?
The b root of x a, x to the power of a, or brackets a to the power of a.
Okay. So we've got that way round. So the b, we have that root. Okay. And the a is then raised to the power. Or, okay, x to the power of a divided by b could also be written as x to the power of a and then to that root. Either or gives you the same result. Now, could you explain why? Neil?
Because x, it's the same base.
I need a nice, clear explanation. It's very simple using one of the previous laws of indices that we can do. Yeah.
Because if you write it out, like if a was like a number, I don't know, then if you write it out like that many times it, like, you know, then it's just the same as just doing x that many times and then doing, it's just because it's the same.
Okay.
Like,
Still a bit unclear, my explanation, but can I point you to the way of, do you remember the law of indices that we had where we said a to the power of m to the power of n can be simplified as a to the power of m multiplied by n. Okay. Remember that one? Okay. So we can use that because we can also write this as a to the power of n multiplied by m. Why?
Because multiplication 2 times 3.
Okay, therefore this could then be written as a to the power of n to the power of m. Right? I can swap those two powers around happily, right? You happy with that? So then all I have to do is figure out, well, how does that apply here? Well, that applies here because what we have, well, where is the multiplication there? So we've got a to the power of, sorry, let's do a to the power of m divided by n. Let's do it in this way. Where's the multiplication?
A times a times however many a's n over n says.
No, I want to split this up.
A raised to m.
Oh!
A to the power of m multiplied by
1 over n.
1 over n. That would give you m over n. Which could then be written as a to the power of m to the power of 1 over n. Yeah? Got that? Right. Or a to the power of 1 over n to the power of n, which is what we were doing. We were doing that second one, yeah. All right? So by the way, if you think about your criterion assessments, I've got a rule. What have I just done? Justified it. Yeah? Have justified it. So this is the kind of thing that you need to, if you want to get to the top levels. So when we start talking about proof within mathematics, not about, well, it kind of looks the same, and you know, it's kind of just, yeah, it does. And, you know, I've given you, there's nothing there to argue against. We know the properties of multiplication. We know how to make a fraction into an integer multiplied by a fraction. We can do that, can't we? We've got all those things. All right. Made sense? Oh, it flips it. Yeah. That's what we can remember as a shortcut. That's what we can link to, but we hopefully will remember why. Right? Why does a negative flip a fraction upside down, a negative exponent? Remember yesterday? Sam?
That is because when you like multiply by 1 over something, it was dividing by that number.
Yep. It's that rule, isn't it? So it's understanding that process. Okay, we've got happy with that. So if I then said to you, little quick question just so you understand. Evaluate 32 to the power of 2/5. Go for it.
Like a police solve.
With no calculator. Evaluate. No calculator. Yeah, right guys. There are certain numbers that you're going to need to get in your head. Right? And this is one of them, 32. So how do I rewrite it? I think of that as the 5th root of 32, then square it. Or 32 squared, okay, and then the 5th root. Which one am I going to choose?
The first one.
Right, I'm not going to try and do 32 squared without a calculator. Right, that gives you a clue which one to use. So I'm going to do the 5th root of 32. And I know that is 2. 2, 4, 8, 16, 32. Done. Yes. All right. And then we square that. And I get the answer 4. So what are the numbers that would be a good idea for you to remember with this kind of stuff? All right. Well, I'm thinking, yeah, anything that links to 2, 4, 8, 16, 32, 64, yeah, 128, anything like that, you know is a power of 2. Then we've got the 3, the 9, 27, 81. Okay, all right. Yeah, certain ones we tend to stop when they ask you a question to do without in your head, but those definitely. Okay. All right. I would even go. What have we got? 5, 25, 125. Okay. 625. Just wanted it louder.
Oh.
Just checking. All right. Is this number one to know?
Yes.
Is it a power of anything?
No.
6 cubed. There's a useful one. Okay. So some numbers, like these, you are yeah, it's going to be difficult to maybe remember them, but they're the ones that I kind of would expect you, without a calculator, to be able to work out. It's power of 3. Now I just need to work out what power of 3. Yeah, it's a power of 2. Right, which power? Just count up on my 50 if I need to. Yeah. All right, but without a calculator, we ought to be able to. The first step is to remember and try and identify certain numbers. And there's not a huge list of them, all right, because if they're expecting you to do it in your head, all right, then it can't be a massive list. It can't be too difficult, all right. So we've got a couple of things just to finish off then. The important things are there are going to be certain numbers that you need to remember. You need to know that you can do it either way round. Okay. Final exit ticket question. Okay. Got that? What power could I give it? A power of